Okay, we just keep moving into more and more complexity. Notice now we have square root minus a square root is equal to a -1. Well, we can only isolate one of those square roots at a time. If we try to multiply this by squaring this whole thing, we'll end up with a messier problem. So we're going to isolate one square root at a time, and then we'll have to do it again when we're done. So we'll isolate this one by adding this square root to both sides. Okay, so what's going to happen here? And I end up with the square root of 2x plus 11 is equal to square root 5x plus 1 minus 1 outside. Now we're going to get rid of one of those square roots by squaring both sides. This one undoes this one, leaving 2x plus 11 is equal to, well, when we write this, it's again going to have to be that using your FOIL process. Okay, so the easy part is this one times this one, which is going to give you 5x plus 1. Okay? Now, -1 times that and -1 times that will give you a -2 times 5x plus 1, because we're going to end up with 2 of them. Okay? And then -1 times -1 is plus 1. Notice, plus 1 is going to give us a plus 2. So we have 5x plus 2 minus 2 times the square root of 5x plus 1 is equal to 2x plus 11. Now, we can get rid of this by subtracting it from both sides. Okay, and now this is going to give us -x plus 9 is equal to -2 times the square root of 5x plus 1. Now, we want to get rid of that square root. So, we're going to put it in parentheses and square it. And we're going to square this one as well. Remember, you have to do it to both sides. So this will be an x squared minus 18x, because minus 9x is -18x, and then plus 81 is equal to -4 times -4 is 4, and we're squaring that, which leaves you with 5x plus 1, because the square will undo that and square that. So now we're going to go ahead and distribute and get 20x plus 4, and over here I have x squared minus 18x plus 81. Subtract 20x from both sides, and also subtract the 4 from both sides. That's going to give me 0 over there, and I'll end up here with x squared minus 38x, and then plus 77. Made a mistake here. This is 3x. So this is 9x squared. That's 27. This will be -54. Makes a big difference here. Okay. See, it's easy to make mistakes on this. 9x squared. And now this one is 54 minus 20 gives me minus 84x plus 77. 74x. Okay, get my numbers right. All right, so now what's going to happen? We're going to have to factor this thing. If I go 3 and 3 on this, 3 times 7 and 3 times 11 aren't going to get anywhere near 74. So let's go ahead and do a 9x and an x. And x squared. Okay, 77, you've got 7 times 11. Well, if I do 7 over here, they're both going to be minus. 7 times this is 63, minus, how about x and x? Minus 11 will be 74. Yep. See, negative 11x minus 63x, that gives you negative 74x. Exactly what we need. So, this is all equal to 0, equal to 0, equal to, well, we're at 0 at that point. Over here, it's equal to 0. Okay, now each one of these equal to 0. So 9x is equal to 11, x is equal to 11 ninths, and x is equal to 7. Okay, what happens? Now we need to check for validity. All right, so I'm going to have to erase some to gain some room to do my checking for validity. Again, you have to check for validity because of the fact that it has been squared. So, square root 2 times 11 ninths plus 11 minus 5 times 11 ninths plus 11. Does that equal negative 1? Well, this is 22 ninths plus 11 under a square root minus 55 ninths plus 11, no, plus 1. Does that equal negative 1? Well, what is this going to give me? If I get common denominator, this is going to be 99 ninths. So this is going to be the square root of 121 over 9 minus square root of, this will be 9 ninths, so that will be 64 over 9. Does that equal negative 1? 121 over 9 is 11 over 3 minus 8 over 3, which is equal to 3 over 3, which is equal to 1. Does 1 equal this negative 1? No, that is not equal. So therefore, 11 ninths is not valid. It's not a valid answer. The last one is to put 7 in. That one will be easier done. Square root 2 times 7 plus 11. 14 plus 11 is square root of 25. Minus 5 times 7 plus 1. So 35 plus 1 is minus square root of 36. Does that equal negative 1? 5 minus 6 equals negative 1. So yes, that does equal negative 1. So this is a valid answer. As you see, 1 was valid, 1 was not. And that's how important it is to check everything. Okay. Now we're going to move up to a little more difficult because we're going to move to cubes instead of square roots. We're going to do the cube root. principles are the same, isolate and undo, unless we have to do more than that. Okay, so let's look. I don't think these will be that much more. Okay, so cubed root of p minus 1 equal to 2. It's isolated, so undo the cubed root by cubing, and I get p minus 1 is equal to 2 times 2 times 2 is 8. Add your 1, so p is equal to 9. And if we put that in, we'll get that, okay? Cubed roots are not as inclined to be extraneous roots given. Okay, let's do a fourth root now. A fourth root of 2k minus 5 plus 4 equal to 0. Now remember, when you're doing this, we have to isolate this, and it's not isolated. So subtract your 4, and we end up with the fourth root of 2k minus 5 equal to that negative 4. It is an even root, just like the square root is. This produces a positive number. Therefore, it cannot equal that negative 4, and therefore this one is no solution. You do not need to take it any further. Okay? Because this is positive and that's negative. Okay, let's look at one more. Fifth root. Okay? Of x squared plus 7x plus 2 is equal to the fifth root of x squared plus 6x plus 1. Notice, everything is under the fifth root. Fifth root equal to fifth root. Undo it simply by doing the opposite, which is taking the fifth root on each side. It undoes that. This one undoes this, and you're left with x squared plus 7x plus 2 is equal to x squared plus 6x plus 1. Subtract those x squareds first. Notice, they cancel each other out, and you're left with 0 on the x squared. So you have 7x plus 2 is equal to 6x plus 1. Subtract your 6x from both sides, and this is going to give you x plus 2 is equal to 1. Subtract that 2, and x is equal to a negative 1. Now, we can check it by simply putting it back in. So, fifth root, negative 1 squared plus 7 times negative 1 plus 2. Does this equal the fifth root of 6, not 6, negative 1 squared plus 6 times negative 1 plus 1. Well, this is 1 minus 7 plus 2. That's going to give you a negative 4. So we have on this side a fifth root of a negative 4. How about this side? 1 minus 6 plus 1, that's also equal to a negative 4. So on this side we have a fifth root of a negative 4. Since we have exactly the same thing on both sides, this is a valid answer. Therefore, x equals negative 1 is valid.